Hey guys, welcome back. So today we are going to determine the volume, mass, and density of a golf ball. These are great golf balls, the Bridgestone, what are these guys? Tour B330, okay, and they have the B330 RX and the B330 RXS. These are great balls. Bridgestone makes great golf balls. And we're going to determine the volume of a golf ball. And to show you how to do that, I'm actually going to determine the volume, the mass, and the density of a marble. Okay. So the first thing we're going to do is we're going to learn how to get the mass of some object, right? In this case, a marble. So let me show you something. So this is your instruction sheet. Okay. So it looks overwhelming. So we're going to go through every single step in video. And so we're starting with station 1, which is mass, okay? And so here are the instructions in writing, but I'll show you what we're gonna do here. So come along, friends. It's time to get up and walk over to the gram balance. So we have a gram balance over here, and this guy is a triple beam balance. You can see him, you'll see him in a second. It doesn't sound great. I'm moving backwards and you'll be able to see him nice and clearly. So there's the triple beam balance, okay? And so in order to figure out how much something weighs, you have to take these guys here, which are called counterweights, and you push them all the way to the left. And after you've done that, you'll notice that the beam balances at a certain spot. So it sort of balances naturally right there. And that's where we're going to return the beam to. Okay, that's the point where we're going to return the beam. So there's the marble. This marble just wants to roll, roll, roll. Take it easy, Broseph. Okay, so that one's a little bit tough to deal with, but I'm going to suck it up. So I'm going to move this counterweight over 100 grams. Okay, so if I move it over to the 100 gram mark, right, that's way too much. And so I'm in a bad spot there. So I have to leave it there. Okay, so this marble does not want to behave. So 10 grams. No, the marble weighs more than 10 grams, 20 grams. The marble weighs right about 20 grams. I'm going to have to stop this marble from rolling. I'm going to have to accept that I'm introducing a little bit of experimental error here. We're going to assume that this piece of paper has a negligible weight for our purposes. Okay, so now this guy is where he goes. He's really close, maybe a little bit too heavy, hard to tell. I'm going to move this guy back over to 10, and then I'm going to start moving this little guy on the bottom over. So this smallest counterweight. Yeah, so now this thing is starting to come into place here, and that's a little bit light. We want to get that guy back to its original position. So now that beam is almost there. I'm going to move it right there. That looks a little bit too much. So I'm going to move it back a smidge. Let's call that perfect. So that is 10, 19.3. That's 19.3. We'll call it 19.38. 19.38 grams. Okay, 19.38 grams for this marble. And then if I take this off of here, you can see that it's really not affecting the balance. Move this guy over here. Ooh, that actually does affect. How much does it weigh? So I had 19.38. How much does a paper towel weigh? Paper towel weighs, wow, has a little bit of weight to it. Let's calculate it. Paper towel weighs roughly 0.25 grams, okay? So 19.38 minus 0.25 is gonna give you 19.13 grams. Okay, the marble is 19.13 grams in mass, okay? And if you had any trouble following that business with the paper towel, don't worry, your golf ball won't require you to put a paper towel on top of the mass, okay? The golf ball has dimples. which help it fly better than it would if it didn't have dimples. Okay, so marble, not flying. Okay, we're gonna say the marble, whoop, whoop, whoop. The marble has a mass of 19.13 grams. Okay, so let's go ahead and put that. You're gonna do this in your notebooks. I'm gonna do this in a spreadsheet, okay? And you're gonna forgive, you're gonna forgive me that luxury. So 19.13 grams, okay? That's the mass of my marble. Okay, what about the volume? Okay, so next what I wanna do is I wanna calculate the volume of this marble from a beaker. So I've got a beaker here. This is a beaker. And this beaker has a water level. Don't put liquids over your electronic devices. This is a dumb move from dear old Dr. J, but he's pretty good at making sure things don't spill. So this one, if you can see there, it's got a volume of 120. It says roughly 125. That's 100. So the 100, golly, so hard to see. The 100 is right there. The 150 is right there. And if I hold this guy really flat, like level with the ground, the water levels out at right around 125 millimeters. Sorry, milliliters. That's the volume unit, milliliters, which is actually the same as a cubic centimeter. Now, I'm going to take this marble and drop it into the beaker. Okay, so marble goes into the beaker, and the water level in the beaker rises. And I'm going to measure how much it's gone up. So if I look at it from the side very carefully, and I'm going to do this, like, can I do this on camera? Okay, here's the beaker. I'm looking at it very carefully. It looks like it's gone up, about right about 20 milliliters. Okay, so I can't get any more accurate than that. So I'm going to call that 20 milliliters. So let me share my screen here. So best I can do is 20 milliliters. That's what I'm calling that. Okay, I've got like one significant figure there. That's brutal. All right. And so now I'm going to use a method called displacement. Okay, what in the world is displacement? Well, I'll show you. Now I've got over here a larger beaker. Okay, and I'm doing this with this marble. I could actually do this with a graduated cylinder, but I'm going to do this with a beaker because you're going to have to do this with the beakers we have. You're going to have to use a beaker to do this with your golf ball. So the first thing I'm going to do is I'm going to fill this beaker up until it's almost overflowing. So I have to be very careful to do that. So I'm going to back up from my keyboard here. And I'm dumping this water into this beaker. And I'm going to get it to almost overflow. Ooh. Very careful. Now I'm going to pour this, I'm going to not pour, but I'm going to place this beaker into a much bigger beaker, which is off camera, but I'll bring it on camera in a little bit so you'll be able to see. I'm trying not to spill any of this water. Okay, so now that beaker is in there, and I'm going to take the marble out of this guy here, and I'm going to fill this beaker up to the very top until it's right about to overflow. Okay, and that's the best I can do. I guarantee you, if I tilt this thing at all, and I'll show you what it looks like. I'll move the camera to do so because I don't want to move this thing. So I've got this beaker in here, right? And it's this beaker inside of a larger one, and the smaller beaker is absolutely full of water. Okay, and I'll see if I can't add like a tiny little bit more water to it. Let me pause the recording and come back. Okay, so I used this graduated cylinder to add some more water to that inner beaker, and that thing's almost overflowing. I'm afraid to fill it anymore. So, you know, this is a tough method to execute because you don't want your beaker to overflow. This like displacement method is really tough, but let's go ahead and give it a shot here. So, and I'm going to take this, let me move this guy so you can see. I'm going to take this marble here and I'm going to drop it into the beaker. When I do, you see a bunch of water goes over the side. Okay. And now I'm going to very carefully try to lift this out without spilling too much water. And I'm able to do so without spilling any. I'm not sure whether that's a good thing. but here it goes. So I managed not to spill any water. And I don't know if that helped my measurement or hindered it actually. But this is the amount of water that the marble displaced. And I guess that looks like about a marble's worth of water. I don't know. I'm gonna pour it into here. And this graduated cylinder will tell me. So the graduated cylinder tells me I've got, if you read, when you do one of these measurements, you wanna read from what's called the bottom of the meniscus. So if you look really carefully, really closely, I have to make this level with the ground, the camera's axis. If you look very carefully at this guy, you'll see that the water kind of curves. And the very bottom of that curvature of the water is this little blue line. And that blue line represents 5, I'll back this off, that represents 5 milliliters. So we're gonna call this 5 milliliters, okay? I've got 5 milliliters there. 5 milliliters of volume. That's a little tough. I don't know if that measurement's any good at all. So I got 5 milliliters. Okay. And then the next thing I'm going to do is try a different method, because these methods I've been using so far, they're like, this method with the mass was good, but this method with the beaker, that's a little brutal. I'm going to try a different method to calculate the volume of this marble. And so what I'm going to do is I'm going to take a piece of paper that I've cut with some scissors. So I cut this piece of paper. I cut a little strip of paper from a larger piece of paper, obviously. And then I'm just gonna wrap this paper around the outside of the marble as tightly as I can. Okay, that's as tight as I can get this thing around the widest portion of the marble. And then, so now that I've got this guy tightly wound, this piece of paper tightly wound, that you see this right here is the little spot right there, that little notch there. That's where the initial, I'll try to move this so you can see it better. Yeah, right there. That's where the paper starts to wrap back on itself. I want to make a mark right there. So I mark it right there. Right there. So that's where I'm going to cut this paper, and then I'm going to measure how long that little piece of paper is, you know, for one full revolution around the marble. So I let it go, and then I cut it like right there along the blue line, best I can do. And then I'm going to take a ruler and measure how long this guy is. So here's my ruler. We're going to start this guy at 0. When we measure him to the left, what do we get? So we get that he is roughly, let's back that off. I'm going to call that, and we'll put this up against my black hair so you can see the end of the white a little bit better. Golly gee whiz. That's roughly 7.5678. I'm going to call that 7.82. 7.82, okay? 7.82 centimeters long. That's the diameter of my marble. So 7.82 centimeters. Okay, but that's the volume. So I'm getting the diameter. So the diameter is 7.82. We'll do a calculation later on to get this volume, okay? All right, and then I've also got a C-clamp. C-clamp, so that's what this thing is. Mr. Rupert let me borrow this guy. It's called a C-clamp. And what I'm gonna do is I'm gonna clamp this guy down onto the marble. And okay, so here I've clamped down onto the marble, right? And I'm gonna measure the space between this end of the clamp and this end of the clamp to get the diameter of the marble. Okay, so oh, did I say diameter? My baggage. I meant circumference. We just measured a circumference. Circumference. Okay, circumference. So that's what we measured. That's how you spell that word, right? Yeah, circumference. Okay. There's there are 3 E's in that word. Okay, very good. All right, so let's go back to this guy. So here's the C clamp. And can I get the marble out of here? No, I can't. And the reason is that there's like a little indentation in this little part here that I'll show you in a second. So that's why the marble doesn't come out. I'm going to loosen it just enough so I can get the marble out. So that's as loose as I can make it. I pull out the marble. And if you look, you see how there's a little indentation there? There's like right there inside there. The marble kind of wedges in there. And so this thing closes around it a little tighter than it should. So what I actually want to do is I want to measure this thing kind of at its widest point. And I'm going to measure from right here to right there. And that looks to me like 2.50. I get 2.50. Might be a little hard for you to see, but I get exactly 2.50. So I get 2.50. I think it was turned around for you, but you'll take my word for it. I get 2.50 on that diameter. And then we got one more to do. The diameter from some calipers. Okay, calipers are great. So calipers also borrowed from the wonderful Mr. Rupert. These guys are digital, okay? They start at 0 and they measure in millimeters, okay? And you know your unit is millimeters because it says millimeters. So you measure the guy at its widest point, and then I just make sure, like, so it see how it's getting smaller, no good. It's getting bigger, good. Good, is that as big as it gets? Smaller, yes. It's about as big as this thing is gonna get. So it says, I can't read it because it's backwards to me. So something 0.4. Something 0.4. What's this? 20. I have to turn this thing around. I think it said, what is it, 25.4 or something? 24.4. 24.4. Okay. I get 24.4 millimeters on this guy. So let's see, 24.4 millimeters. That means 2.44 centimeters. So I have to put in here, I have to put 2.44 centimeters. Okay. So now I've completed all of my measurements. All right. But remember earlier, I said we wanted to calculate the volume. We wanted to calculate the density. What about those calculations? How do you get volume from these other measurements, right? What do you do with these volume measurements? How accurate are these guys going to be? And then how can you use the mass along with volume measurements to determine density? Those are things that we will discuss next time.